All right, it's time to get ready for our Unit 9 test. And so the first thing we're going to do is sketch a graph, list the domain, range, y-intercept, and the asymptote. And so for this first problem, it's moving up 1 for the asymptote. And so that's going to be y equals 1. We're going to the left 2, so 1, 2. That's going to be kind of my guide point. And from there, my starting point is 3 away from the asymptote, so 1, 2, 3. And then my rate is doubling. And so every time I move to the right, I'm going to double how far I am from the asymptote. So this is 3 away, then I'm going to be 3, 4, 5, 6 away, and then 7, 8, 9, 10, 11, 12 away. Or half of 3 would be 1.5 away, 0.75 away, and it's going to keep cutting closer and closer to the asymptote, but never touching it. And so my domain is all real numbers. Every time my range on this one goes from 1 to infinity without touching the 1. So it's a parentheses. And my y-intercept is at 13, 0, 13. All right, on this one, we're going to go up 1 again. So there's my asymptote, y equals 1. This one's going to go to the left 1, and we're going to start just a fourth away from the guide point. So right there, close to the asymptote, but not touching it. Then we're going to quadruple on this one. So this was a fourth away. 4 times a fourth is 1 away. 2, 3, 4. And then 4 times 4 would be 16. So 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16. There we go. All right. My domain again is always all real numbers. My range goes from 1 to infinity, and my y-intercept is at 2, and so 0, 2. All right, this one's going to be a decay because that b is in between 0 and 1. We're going to go up 2, and so my asymptote's going to be at y equals 2. We're going to go left 2, so 1, 2, and our starting point is 4 away, so 1, 2, 3, 4. And then every time we move to the right, we're going to cut in half. So this is 4 away, and so 1, 2 away, and then 1 away, and then half away, and a fourth away, and it's going to keep cutting in half. Or the other way, we can double it. So it was 4, 5, 6, 7, 8, and it would keep going up that way. So once again, my domain is all real numbers. My range is from 2 to infinity, and my y-intercept is at 0, 3. All right. And then we're going to list all of my transformations. And so on this one, the 2 is going to be a vertical stretch by 2. We're going to the left 4. And we're going down 1. Now we're going to have to reflect over the x-axis because of that negative. We're going to be a vertical compress. We're going to be going to the right 2 and up 7. All right, so on this one, let's see, that's 1 away, 2 away, 4 away, so we see it's doubling every time. So we're going to have 2 to the x. My asymptote has been shifted down 1, so we have a -1 at the end. Oops, I put a 7. -1 at the end. And then we're going to look for the dot that's 1 away from the asymptote. So here's the spot that's 1 away from the asymptote, and so that went to the left 1, so x plus 1, and that'll be it. Same thing on this one, 1 away, 2 away, 4 away, so this one is doubling again. Here's a spot that's 1 away, moved to the left 2, so x plus 2, and it got shifted down 1, -1. All right, to solve these, we need to get the same base on both sides, so 9 and 81 both would have the base of 9. So 9 to the negative first is 1 over 9. 9 to the negative second is 1 over 81. Anytime there's a fraction, that means we're going to have a negative exponent. And so that means that's going to be negative 2x is equal to negative 2x plus 4. We'll add the 2x over. It's going to cancel on both sides. We got 0 equals 4, which isn't true, so this one's no solution. 36 and 216, we're going to have a base 6 on both sides, so the 36 is going to become 6 squared. And the 216, if you're not for sure, you can go into your calculator and kind of play with it and go 6. Well, 6 squared was 36. Let's go 6 cubed. There's 216 right there. So 6 cubed is 216 to negative 2p. So we have negative 6p plus 6 is equal to negative 6p. We're going to add the 6p over. And once again, we get a non-true answer, so no solution. All right, 8 and 64, we could use 2 or we could use 8. I'm going to go ahead and use 8 since it's already there. 8 to the negative n equals 64 is 8 squared. And so negative n equals 2, so n equals negative 2. And you can always check these as well. You can take that negative 2 and you can store it in for my x. And then we can just check it. 8 to the negative x is equal to 64, so it checks. On this one, 4 will work on both sides, or 2. I'm going to go use 4. And so 4 cubed is 64. And so we're going to have 4 to the negative third, because there's a fraction that's going to be a negative exponent. And so we have negative 9r minus 6 is equal to 3r. And then we'll add the 9r over. So negative 6 equals 12r. And then we'll divide by 12. So r equals negative 1/2. Negative 6 over 12, which is negative 1/2. And then again, we could check it if I wanted to. I could put negative 0.5, which is negative 1/2, store that in for my x. And we can put it in. So 1 over 64 raised to the 3x plus 2, and that equals 1 over 8. And then on the other side, we can do 4 raised to the 3x, 0.125, and 1 divided by 8 is 0.125. So they are the same thing, it checks. Sorry, there's my calculator to see what I put in. All right. So 125 and 625, I believe we're going to have 5, and so just to check, we can do 5 to the third power, that's 125, 5 to the fourth power is 625, so there's my numbers. So 125 becomes 5 cubed, 625 becomes, oops, I don't know why I put a 6, 5 to the fourth, and so we get 3m equals 4, m equals 4/3. 8 and 64, I'm going to use 8, so that's going to be 8 to the negative 1. That's going to be 8 squared, so negative 2m equals 2. M equals negative 1. All right, if a town with a population of 5,000 doubles in size every 7 years, what will the population be? There's no percentage, so on this one I'm going to use the equation y equals ab to the x, where a is going to be my starting point and b is my rate. So on this one, my starting point is 5,000. My rate doubles, so that's going to be a 2. But this time it doesn't double every year, it doubles every 7 years, which is going to be x over 7. And my population 14 years from now, so I'm going to plug in 14 for that x. And so in our calculator, I'm going to just put in 5,000, 2 raised to the, and you can put 14 divided by 7, or you could just put 2 because they're the same thing. 14 divided by 7 is 2, and so we get 20,000. On this one, it said it triples its size every 85 years. If the population is currently 50,000, and we're tripling, and on this one, we're going to be x over 85, and so I'm going to plug in 170 right there, and so we're going to put it in the calculator, 50,000. We're going to triple 170 divided by 85, so 450,000. There's a population of 50,000 bacteria in a colony. The number of bacteria doubles every 4 minutes. Well, the population would be 18 minutes from now. So we have 50,000, and it's doubling every 4 minutes. And so we're going to plug in 18 up here. So we're going to have 50,000 doubling, 18 over 4. All right, after it has been harvested, corn stored at a particular temperature will lose market value at a rate of 5% per day. So this time we do have a percentage, so we're gonna use the A equals P, 1 plus or minus R over N raised to the NT. This one doesn't have compounding though, so I don't have to worry about the N. If a corn harvest worth 11,960, that's our starting amount, is being stored at room temperature, and we're going to subtract, because we're losing value every day, 0.05, and that's per day and in 10 days, so we're going to raise it to the 10th power, and so 11,960. 1 minus 0.05 and raise it to the 10th power, 7160.89. An investment of $75,000 increases at a rate of 12.5% per year. Find the value of the investment after 30 years. So again, no compounding. So we're going to start with $75,000. We're going to increase it by 0.125 and go to the 30th power. So it'll be 2568247.87. There we go. Kelly plans to put her graduation money into an account and leave it there for 4 years while she goes to college. She receives $750 in graduation money that she puts into an account that earns 4.25% interest compounded semi-annually. That's twice. How much will be in Kelly's account at the end of 4 years? And so we're going to have $750, 1 plus 0.0425, over the 2 times it's compounded raised to the 2 times 4. So we'll go into our calculator and put in 750. Oops. 1 plus 0.0425 divided by 2 raised to the 2 times 4, which is 8. And so in 4 years, she'll have $887.40. William wants to have $4,000 in 2 years, so that's his final amount. So he can put a hot tub on his deck. He finds an account that pays 5% interest compounded monthly. That's 12. How much should William put into his account so that he'll have $4,000 at the end of 2 years? So we're going to find the principal. 1 plus 0.05 over 12 raised to the 12 times 2. So on this one, we're going to put this in our calculator to start off. And so 1 plus 0.05 divided by 12 raised to the 12 times 2, which is 24. And so we have the P times that. And then to get the P by itself, we're going to divide both sides by that 1.049. So the easiest way to not round, in our calculator we're going to take the 4,000 and we're going to divide by, and we'll copy and paste that down by highlighting it and pressing enter. It'll bring it down, and so we need to invest at least $3,620.10 to get about that $4,000. All right, the exponential regression. Census counts wolves began in 1990 and produced these estimates. And so we need to find the exponential function. So we're going to go into our calculator and we're going to press stat. We're going to click edit. And I'm going to go ahead and delete all these numbers. And we're going to have 0, 2, 5, 7, 10, 13. I'm just going to put them in just as they are. 100, 300, 500, 900, 1500. And 3100. And then we'll go back into stat. We're going to go over to calculate and go down to the 0 option, which is XPreg, exponential regression, and it brings up our equation. So it's going to be 138.37, 1.28 raised to the x power. And so in 1993, that's going to be 3 years. So I'm going to plug in my 3 into my x. And so 138.37, 1.28 raised to the 3rd power. And so we expect there to be about 290 wolves. All right, based on that equation, which doesn't match up with the table too much, but that's about what we would expect based on the equation. All right, hypothermia is a life-threatening condition in which body temperature falls well below the norm of 98.6 degrees. However, because chilling slows normal body functions, doctors are exploring ways to use hypothermia as a technique for extending time of delicate operations like brain surgery. And so here's our table. Write an exponential function that most closely represents the data moving. All right, and so we'll go ahead and put this in our calculator just as it is. And so stat, edit, 50, 59, 68, 77, 86, 98.6, 11, 16, 24, 37, 52, and 100. Go back into stat, we'll go to the 0 option. And so at 39 degrees, the lowest temperature that's been used in surgery experiments on animals, we'll plug that into our x. And so we have 1.13, 1.05 raised to the 39th power. 7.58%. All right, and that completes our review. Let me know if you have any questions.